WK351, it's James here. We're in chapter 17 and we're talking about the chi-square goodness of fit test, and we're going to go through the example that starts on page 286, and we're talking about level of education. And here are data from a sample collected at random from a 1990 census that was collected in Sonoma County, California. And so we have the summary of the information. We have 3 levels of education, which is no college, some college, and a college degree. And the question of interest is whether the number of respondents is equally distributed across all levels of education. Well, if they really were equally distributed, then we'd have the same frequency for each of those 3 categories. To answer this question, the chi-square value was computed and then tested for significance. In this particular example, we'll see that the chi-square value is equal to 11.643, which is significant if we have our critical value of alpha set at 0.05. So we need to write our null hypothesis and our research hypothesis, and those are given to us on page 288. But in terms of English, our null hypothesis is that those 3 proportions are the same. So if we have 3 categories, then in that particular case, we would assume it would be 1/3 for each. So 0.333, 0.333, 0.333. The P in the null hypothesis represents the percentage of occurrences in any one category. For the research hypothesis, all we're saying is that there is some difference in the frequency or proportions. We're not stipulating where exactly that happens, but we're just saying that there is some difference somewhere. For step number 2, we're going to set our critical value. We've been using that 0.05, and so when I look at this web page right here, I'll give you access to this in 2 different ways. This right here is the full URL address. If you want a shortcut, this is the shortened URL that we used, and I can make this bigger here. So you can type in this shortened URL. It's http://bit.ly/18WN7DQ. And if you type that into your browser, it will take you to the same website here for this chi-square calculator of goodness of fit. And here's how we do this example. We have 3 categories. We have no college, then some college, and lastly, college degree. And as we showed last night, we have these 3 categories. As long as we leave these next 2 blank, the site automatically detects that there are just 3. And we could do it off of the frequencies or the proportions. Now we have information on these frequencies, so we're going to actually type in the actual frequencies here. So we have no college was 25. Some college was 42. And a college degree was 17. Now our expected, since we're dealing with the frequencies here, our expected is we're expecting the same in each of these 3 categories. So what we need to do is compute the mean for these 3. So if we add up and divide by 3, well, the sum of these 3 values is 84, and 84 divided by 3 gives us 28. We're assuming that these are equal. So we should have the same number in each of these 3 categories. As we discussed last night, We can already see that there are some differences, and the question is whether or not those differences are statistically significant. And we're choosing our significance level of 0.05, and we're ready to calculate our chi-squared value. And I think for your homework question, I'll double check on this. I think you may have, yeah, for the homework we do have alpha set at 0.01, so you'll have to customize this for that particular homework. But here we have alpha equals 0.05, and we're ready to run the chi-squared. So we go ahead and do that, and this gives us all of the values that were used to compute the chi-square. And the chi-square is 11.643. That agrees with what we have in the textbook on the bottom of page 286. The p-value is 0.003, which is less than our alpha value of 0.05. So we conclude that the result is significant at the p is less than 0.05. So we reject the null hypothesis, and we have to choose in favor and to say that the more attractive explanation is our research hypothesis, that there is a difference in the frequency or proportion. So this would be the frequencies. There is a difference, a statistically significant difference in the frequency of occurrences in these categories. So that's our goodness of fit example from the textbook.